Okay. Good morning. Okay. First of all, I will type how you finish the assignment. Yeah. So first of all, I will invite one of you to perform the exploratory factor analysis using this data. Yeah. Anyone? Try? Yeah. Thank you.
So, first of all, I saw that our professor already copied from this name to the number already. So, to do the EFE, we have to go to Analyze, and then dimension reduction and factor. And then we have to select and KMO, then continue. For this part, no need to change because the eigenvalue is greater than 1. That's right. The third one, we have to click Varimax. And this one no need to change. This part we have to click sort by size and separate. Then, so we can see the factor analysis here. And we see that KMO is so high. So it's really good. It's greater than 0.8 something. And also we look at some factors for the component matrix. What do you notice in this table? Do you have any notice in this table? We have 5 that factors, 1, 2, 3, 4, 5. And what do you notice from this table? Which factor that you think is the cross-loading? Which?
Okay.
Oh yeah, right. Sorry. Yeah, this one. The last set application.
What?
This one? Last one.
Yeah.
Yes. The distance between what? 5.564 and 0.441. So it's a gross loading. So I would like to ask the professor, we have to remove this or no need?
What?
We have to remove this factor or no need?
Which factor? The atom.
The atom.
With cross-loading, right?
Yeah.
Yeah. Okay, I will explain that later. Yeah. So you finish this part first. That's all?
That's all.
That's okay, thank you. Thank you, Professor. Yeah. Okay, so first of all, I try to explain the atom with the cross-loading issue. So it depends on how you deal with the data. For example, if this is a new scale, you develop a new scale. In this case, we are very strict with quality of the data and quality of the scale. So in this case, you have to remove the atom with cross-loading. Otherwise, for example, you merely use the scale, and the scale has been validated in prior studies. So in this case, you can consider, if you are strict, you can consider removing this atom as well. You can also consider keeping this atom. Because although there is a cross-loading, but for example, this one, the cross-loading on the fifth factor is still the highest, right? So you can consider keeping this atom. So it depends on your research aim and how you deal with the data. Yeah, that's the issue. Okay, this is the procedure is correct. Good, very good. And but here I want you to check the result again and see. So just now we know that there is cross-loading problem. What else? What other problems can you find in this data? Any other problems? In addition, cross-loading. Yeah.
We see some blank spaces there, and
Yeah, we can see the blanks here.
which means that the controlling has been suppressed because they are less
Too small. Yeah, too small. Yeah, if they are too small, they are smaller than 0.1, they won't be shown in the table. Yeah, that's true, but it's not a problem. It's how we ask the software to ask the software to present the findings and problems. Okay, let's check. So first of all, how many factors are we expecting? 5. How many factors we expect? How many?
5.
How many? Bridging, right? First one, bridging, bonding, yeah, efficacy, leaders apart, intrinsic, extrinsic. So altogether, we expect the data can, altogether 6 factors, right?
Yeah.
Yeah, 6 factors. 6 factors. And in here, how many factors have been extracted? 5. So there must be problem, right? There must be problem. Okay, again, what is the problem?
Intrinsic and extrinsic motivation included 1 factor.
Yes, we expect intrinsic motivation, extrinsic motivation, they are distinctive from each other, right? They belong to separate factors. But here you can see they are combined. Yeah, in 1 factor. Yeah, this is a problem, right? Yeah, is that clear? So you can see all the items of self-efficacy, they go to the first factor, right?
Yeah.
Right? The efficacy, the 10 items, they go to the first factor, right? Yeah. And you can see the items of intrinsic motivation and the items of extrinsic motivation, they go to the second factor, right? So they are not separate from each other. They combine into 1 factor. That's the problem. For others, bonding go to the third one. The atoms of bonding, right? They go to the third factor. Leaders apart, they go to the 4th factor, right?
Right.
Right? Yeah. And bridging, the atoms of bridging, they go to the 5th factor, right? Yeah. These are correct, no problems. The problem is that the atoms of intrinsic motivation and extrinsic motivation, all of them go to the second factor. They combine into 1 factor. That's the problem. That's the problem. Okay. Okay, so next question is, now since we already found the problem, next question is how we deal with this problem. How we deal with that?
Change the factor name.
Change the factor name, like motivation, right? Yeah, yes. So you have to know, if you conduct EFA, and the EFA tell you that they are 1 factor. So in the following data analysis, you cannot treat intrinsic and extrinsic as separate factors or separate constructs. No. It's very simple. The data already told you that they are 1 factor. How can you separate intrinsic and extrinsic from each other? No, that's not reasonable. So you have to follow the result of the EFA in the following data analysis. Yeah. So what you need to do is to change the name of the factor, right? So now we combine intrinsic and extrinsic into 1, so the name of the factor can be changed to research motivation, right? Research motivation. Okay, so in the following data analysis, there is only 1 factor, research motivation. Okay, that's it. Next. I also. Okay. Now I want to use this example to illustrate how to deal with the problems in the factor analysis. Okay. Now, can you understand the result of EFA in this study? Can you understand?
Yeah.
Yeah. For example, here, it says, so factor loadings smaller than 0.3 not shown, too small. Bold underlined loadings included in the data analysis. Yeah. Okay, so these are the names of the constructs, like need for autonomy, and need for competence, extrinsic motivation, intrinsic motivation, and need for relatedness. Okay, the names of the constructs. Okay, now, I have several questions for you. These items, they go to the first factor, right? Yeah, they go to the first factor. Why this item was removed?
Because it belongs to a different contract. It should be five.
Yeah. Yeah. You see, although it belongs to the first factor, but it is the item from a different concept, right?
Yeah.
So it was removed. It was removed. Okay. How about this one? How about this one? The same reason, right? The same reason. Okay. The same reason. These two items from need for autonomy. Okay. It was removed. How about this one? How about this one? There is a cross-loading, right? There is cross-loading. So it was removed. It was removed. How about this one? How about this one?
It's too weak. It's too weak. It's too weak. It's 2.5. Weak. Weak.
So it's too small, right?
Yeah.
It's smaller than 0.5.
Yes.
It's too small, so it was removed. Okay, good. And also, well, let's go further. Okay, my question. Next question is this atom. This one, AUT5. AUT5. Why this atom was kept? Why was this atom kept in data analysis? There seems a cross-loading, right?
But it's
There is a cross-loading, but it was kept.
it's
My question is why?
It's greater than 1.
What?
It's greater than 1.
It's greater than 1. No, no, no. There is a cross-loading, and this was removed, right? There is a cross-loading, but it was kept. What? Not easy to answer.
It's
Uh,
like to separate
separate.
factors.
Separate from what? From each other. But not so separate because there is cross-loading and
Another factor.
yeah, 0.5, 0.38. No,
38 another factor.
yeah, that's the reason. Thank you so much. Huh. Okay, you take a look at this one, this atom. There is a cross-loading, right? It was removed, right? The cross-loading take place between, you see, the cross-loading take place between REL and AUT, right? Right? So these two are the constructs we are going to use in the data analysis, right? So this cross-loading, we have to deal with this cross-loading because REL and AUT are the constructs we use in the data analysis, right? Okay, take a look at this one. Take a look. This one. This cross-loading take place between AUT and the other factor. But can you see that? This factor beyond the constructs we are going to use. Do you understand me? Yeah. This factor, pay attention, this factor is not the factor we are using in the data analysis. Right? So, although there is a cross-loading, this cross-loading will not interfere with our data analysis. So, this cross-loading is not a problem. You understand me? Yeah, that's the reason. That's the reason. And also, you can see COM1 and COM4. They also, yes, the factor not included in our data analysis, right? So they are also removed from the data. Okay, so now you may understand why every detail of the factor analysis, right? Why the atoms remain in the data analysis, why the atoms removed from the data analysis. Yeah, you have to know, understand the reasons. Okay. So much for exploratory factor analysis. We are going to move on to next, data analysis. Previously, we've always been using atoms for the data analysis, right? We've been using atoms for data analysis, right? Yeah, for reliability, for validity, factor analysis, we've always been using the atoms. But afterwards, we are mainly using variables for the data analysis. We're not using the atoms. For example, next one we are going to talk about. We are going to talk about independent. t independent t-test. And when we allow independent t-test and when we allow part of the data analysis. Yeah. So what are we going to use them for what? So you know that in many cases, often we want to examine group differences, right? Yeah, we want to examine group differences. For example, sometimes we want to examine gender differences, right? Yeah, males, females. Are there significant differences between females, and males? Yeah. Are there significant differences? Sometimes we want to examine other group differences. If you want to examine the group differences, we use this data analysis. We use this data analysis to examine group differences. When we use independent t-test, because we want to examine the differences between two groups. We use independent t-test. For example, gender difference. Yeah, we have boys, we have girls in this class, and we want to examine if there are some significant differences between boys and girls. Okay, two groups, right? Yeah. So we use independent t-test. If we want to examine the differences between three groups or more than three groups, three or more groups, we use one-way ANOVA. We use one-way ANOVA to examine the differences between three or more groups. Okay, so this is the data analysis we use often in our papers, in our articles. We often use the data analysis, independent t-test and one-way ANOVA. Okay, so now we talk about t-test first. T-test first. How to conduct this analysis? We follow the three steps. Operation, interpretation, and report. So, for example, you can see here which one is suitable, which group is suitable for t-test. Gender, right? Gender, we have two groups, right? Yeah. Any other? Any other? No. Yeah. Father education level, mother educational level. Two groups, right? Okay. So now we use gender as example. Use gender as example. For example, I want to examine whether there is significant difference between male and female students in terms of A, well, when I say I want to examine whether there is a group or significant difference or there is a gender difference in A, A is a construct, is a concept, right? A is like, for example, A represents motivation. A represents motivation. So I want to examine whether there is a gender difference in motivation, right? In motivation. Okay. So now when I say A, what represent A? Where is the data that can represent A? Where is the data that can represent A? We have only A1 to A6, right? But now I'm going to use A. How to represent A? How to represent A?
Average. Well,
Average, right? Yeah. So here, first of all, we have to compute the mean scores for A. We use A1, A2, A3, A4, A5, A6. We use their mean scores to represent A. That's why. So, okay. Why we use the, for example, I want to examine gender difference in A1. Does that make sense? I want to examine gender difference in A1. Does that make sense? No. No. The atom, it doesn't mean much for atoms. Here we are going to use the construct, the concept, motivation, right? Yeah, so we are not going to examine the group differences or the gender difference in A1. Instead, in A. Yeah, because A represents a concept. Yeah, so we need to, so what is the data for A? We are going to compute the mean scores for A. Yeah. Okay. So now I will show you how to compute the mean scores. Transform. Maybe you can follow me. Or first you take a C, how much? Transform and compute. You open it. Transform, compute. So first of all, you need to give a name, right? You compute the mean scores. So you create a new variable. So you have to give a new name to the variable. So the name could be A. Could be A. And yeah, bracket. We use this is very simple. We use A1 plus A2 plus A3 plus A4 plus A5 and A6. This is the sum, right?
yeah.
Divided by 6, right?
Yeah.
Divided by 6. Okay. Then you press OK. then you can see there is a new scale. There is a new variable, A. Here, you can also see this is A. This is A. Yeah. But you can see there are some blank spaces. Why? There are some blanks here. Why? Because there are missing values. There are missing values. For example, this is blank. It's because you can see here A1 to A6, there is missing data. A4 is missing. It's missing. But now, so some years ago, we often have missing data because we use paper and pen questionnaire. Yeah, we distribute questionnaire in classrooms, and they fill in the questionnaire. So they may miss one or more questions. So they are missing data. But now we use online survey, right? We use online survey. So they have to complete all the items so that they can submit the survey. So there won't be missing data anymore. So, but here in this data, there is missing values. There is missing value. Okay, so this is A. This is the mean A, the mean score, and representing concept of A. Okay, so now every one of you, because in all the following data analysis, we are going to use the mean scores for all the following data analysis. So now please, everyone, you compute the mean scores. You compute the mean scores for A, B, C, D, E. Yeah, so that, and you save the file. You compute the mean scores for A, B, C, D, E, and you save the file so that we won't compute mean score anymore. And also, you compute the mean score for all these constructs. But pay attention. You compute mean scores separately for intrinsic and extrinsic. So, you know, EFA already shown that intrinsic and extrinsic, they are one factor, right? Yeah. So in your own data analysis, you have to treat them as one factor, as one factor. But because we want to use the data as the example for data analysis, we have to use them as a separate concepts. This is for our data purpose. So you have to compute separately for intrinsic and extrinsic. Right? You know what I mean? Yes. Okay. So now you compute mean scores for all of them. Be careful. Be careful. It's not difficult. It's very simple. But you have to be careful because if you make mistakes, all the following data analysis will be problematic. Although it's simple, it's very important. Okay, so now do it. Yeah. Yes, that's right. Because you already computed, so it asks you want to change existing variable because you already able. What? No, 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 no. You see, there is already a. It's already.
No, but Professor what is the second one? Yeah. Professor.
Oh, you use the formula? I'm not sure. It's okay. It's okay, but it's too complicated. You just some up. This is a. Further, further. Yeah. But this is the sum that you have better use these words to sum the number divided by 6. Yeah. Yeah, it didn't do that. You only sum them up.
Yeah, it's
Bracket and divided by 6.
Não, vou vir. Vou conseguir ajudar daqui.
If you have any questions, you let me know.
And here we will divide by 5, right? You do.
Yeah.
We divide by 5, right? Then 4. Then 2. Okay. Let's go. Divide again 3. Six.
Finish.
What do you use?
예. 예, 필드.
A, B, C, D, E.
Só foi uma vez.
A, B, C, D. This is yes.
They are different. Yeah.
Use the bracket, some number divided by 6.
Well, until I finish it.
Yeah. What's wrong? Yeah. Show you. Show you.
Okay.
So bringing the one.
Okay. This one.
One. One. Two. Three. Six.
What's up? So this one.
Yeah, you have each of them.
Everyone, you have
Okay, we have to stop here. If you are not finished, you complete it after class. Yeah. So I will give you one more example. For example, if I want to compute now I want to compute the mean score for B. So I sum them up. So you have to use the bracket, and then you use B1 plus B2 plus B3, B4, B5, and then you use the sum number divided by 5. What? Yes. Yeah. Then you okay. Yeah. Now you have mean scores for A and B. Okay. You complete the mean score after class because we are going to use them afterwards. Okay, so now I want to examine gender differences in A. Gender differences in A. Okay, we go to analyze. Then you can see we compute compare means. Compare means. That's why we have to compute the means, because t-test and one-way ANOVA is conducted based on mean comparison, based on comparing means. So compare means, and then we have not C. Compare mean. Then we go to independent t-test. Independent t-test. You open it. You open it. So we have two blocks. Bigger, small, big, small. Which variable should be put in this place? I want to examine gender differences in A. So which variable in here? A, right? Yeah. So I put A in here. So for this one grouping variable, we put
gender.
the group right in here. So I put gender in here, right? So this is the variable. This is the key variable. This is the grouping variable. Okay, gender in here, and now you can see two question marks. Why? Because the software has no idea of the groups. So you have to tell the software. You have to tell software the two groups are 1 and 2. Then you continue. Then you continue. Why? Because here, you see here, 1 represents male, 2 represents female. So you tell the software we have two groups. 1 and 2 respectively. Then you can see here 1 and 2. 1 and 2. So now I just examine gender differences in A. You don't have to change anything here. You don't have to change anything. That's okay. That's okay. You press OK. Then you can see the table. You can see the table. I explain the table. I explain the table.
So,
Any problems?
no.
So your result is different from mine, right?
Yeah, it's the same exactly. The same.
Okay. So that's the only reason is that you didn't compute the mean score correctly. You can compute. Okay, you can compute A again. You can compute A again. You have to use the bracket and A1, A2, A3. Yeah, and A6 divided by 6. Close. You can see if yours the same as mine here. Yeah. Yeah. You can delete.
You have computed this number. You have computed the number. That's why it is basic fact. Yeah. Check your data. You have included the number. We have computed the value 8.
The result. It's the same.
See with that.
Yeah, from the top. If you do it correctly, it should be like this.
What did they?
It's same.
Same. Yeah.
Yes.
Okay, are you finished?
One.
That's it. It's okay. No, I mean like laptop batteries. Yes.
Okay. Okay, so now let's continue. Now I explain the two tables. So the first table, this is the statistic, descriptive statistics. Descriptive statistics. It tells us the mean values of, for example, you can see the numbers for male, right? So altogether, for example, we can see we have 260 male students. We have 506 female students. And the mean score for male is 4.1. The mean score for girl students is 4.2, right? Yeah, and their standard deviation. So this is the descriptive statistics for male students and female students. Okay, now let's take a look at the second table. It's more complex. It's more complex. Pay attention. In the following data analysis, we'll pay special attention to p-values. We'll pay special attention to p-values. You know the significance levels for p-values. You know that, right? Yeah, I've been repeating the significance levels several times. 0, 0, 5, 1, and 3. That's 0, 1. Yeah, 0, 0, 1. Yeah, 3 levels. You will have to pay special attention to the significance level, to the p-value cut. Okay, so now you check the table. How many p-values here? P-values.
One.
This is p-value, right?
Yeah.
Because this represents significance. This is p-value. This is p-value, right? This is p-value. This is p-value. Okay, now please remember the first p-value. The first p-value it match with f. This is the p-value of f. They are a pair. It's the p-value of f. But the second p-value is the p-value of t. It's the p-value of t. It's the p-value of t. Of t. This is a pair. This is a pair. This is a pair. P-value of f. P-value of t. Okay. How to interpret the result? This p-value, the p-value of f. This p-value can tell us which row you have to check. So pay attention. When the first p-value is not significant, if the first p-value is not significant, you go to the first row. You go to the first row. Why? Because if the p-value is not significant, the assumption or assumed variance, equal variance is assumed. For the data analysis, for this data analysis, we have two assumptions. One is the variance is equal. The other one is the variance is not equal. So when this p-value is not significant, this assumption is assumed. So we can confirm this assumption. So we go to the first row. That's why. But you don't have to understand that. You don't have to understand that. You just remember. If this p-value is not significant, you go to the first row. The first row is equal variance assumed. You go to the first row. Just remember this. Okay, then if this p-value is significant, you go to the second row. You remember this. Okay, for you, in this case, the first p-value is significant or not?
No.
Not significant, right? It's not significant. So you go to the first row, right? You go to the first row. In the first row, when you check the second p-value, the second p-value is 0.003. Is it significant? Is it significant? Yes. Represented by 1, 2, or 3 asterisks.
One.
It's there.
One.
Again, it's 0.003. 0.003.
Three.
Okay. If the p-value is 0.03, 0.03
No signal.
is significant,
Yeah, yes.
represented by one asterisk. Yeah, but actually it's 0.03.
Yeah.
It's 0.03, so it is smaller than
Yes.
it's smaller than 0.01, right?
Right, yes.
So it's represented by two asterisks.
One.
Okay.
Ah,
So this is 0. This is 0.01.
now the p-value. Now the p-value is 0.003.
Yes. So it's this one.
Which value?
Second one.
This one. Right? So it's represented by two asterisks,
Yes.
right? Yeah. Okay.
It is 0.0.
So the second in the first row. Okay, please. Now we know the second p-value in the first row. In the first row, this p-value is significant, right? It's represented by two asterisks. Because it's significant, it shows there is a significant gender difference in A. You understand me? Yeah. Oh. Because it's significant, it shows there is a significant gender difference in A. What are we doing now? We are examining the gender difference in A, right? Right? So this p-value tells us the gender difference is significant because it's significant. Okay. Now we know. There is significant difference between boys and girls in A, right? Yeah. So is our data analysis completed? Is our data analysis completed?
Only one constraint.
No, I just focus on, merely focus on A. Now we are investigating gender difference in A. Now I know there is significant difference between boys and girls and know the result. Yeah, my question is our data analysis completed?
No.
What else?
It's on the ANOVA test.
What?
ANOVA test because the independent variable and the variable is true. We have to do ANOVA test.
Okay. So now what we already know? We already know the significant difference between boys and girls, right? But if you want to report the finding, the result, is that clear to the readers? Is this result clear to the readers? No, the readers want to know boys higher than girls or girls higher than boys, right? Now we only know the difference, but we don't know boys higher than girls or girls higher than boys, right? Yeah, that's the final result. That's the final result. So we want to, the final result should be girls score significantly higher than boys, or boys score significantly higher than girls. That's the final result, right? Yeah. How can we know who score higher? How can we know that? Yeah, you have to go back to the first table. Go back to the first table, checking the mean scores. Checking the mean scores. Who score higher? Female, right? Female. So the final result is what? Final result is females score significantly higher in A than boys, right? Than boys. Yeah, this is the final result. Okay, now I will repeat it again. This table can tell you whether the difference is significant or not. If you want to know what is the significance, you have to check table 1. You have to check the mean scores in table 1. Yeah, so that you know. So please think, please see. If you now you know the result, how you would report the finding. Okay, first of all, can you tell me what might be the important values for independent t-test? What values should be reported? Yeah. What could be? P-value important, right? Yeah. And the p-value, this p-value is the p-value of t, right? Yeah. So t and p important because they can show whether the difference is significant or not, right? So t and p should be reported. Yeah. What else? And yes, and mean scores, and the standard deviations, should be reported. Should be reported. Okay, now can you make a summary of the finding? How you report this finding? How you report this finding?
Difference.
Mhm.
Compare that, there are male is higher than female is than men.
Yes, that's it. Where are the values? Where are you have to report the values, right? Yeah. Okay, good. Thank you so much. So it's very simple. I may sum up, make summary. How you report the finding of independent t-test. It's very simple. So we just say independent t-test. Independent t-test indicates that there is a significant gender difference followed by a bracket. In the bracket, you report what? In the bracket, you report what? P and P, right? Yeah, P and P. Okay, this is the sentence. The first sentence. Then, you can say specifically. Girls score significantly higher than boys in A. Okay, we could say independent t-test shows that there is a significant gender difference in A, right? Followed by P and P, what? Right? Then you say specifically, girls score higher, significantly higher than boys, right? Than boys. Then after girls, you can use the bracket, and in the bracket you can report the mean scores and the standard deviations for girls. Then boys, after boys, you can use a bracket, and in the bracket you can report the mean scores and the standard deviations for boys. That's the complete report for independent t-tests. That's a standard way of reporting independent t-test. Is that clear? Yeah. Finally, finally. So that's the way we conduct independent t-test. Okay, then just now we say that when the p-value is not significant, we go to the first line, right? Oh, no, sorry. Yes, we go to the first row, right? But when the p-value is significant, we go to the second row. We go to the second row. For I don't know if B, we can try. Try B. E, right? We here. Okay. I put B in here. Put B in here.
Should we take out A?
No, no. You can compute the variables together. So this is for B, right? Okay, you can see the first p-value is significant. It's significant. It's the level represent by 1 asterisk, right? Yeah, it's significant. So you go to the second row, right? The second row, the p-value is 0, 0, 0, right? It means that there is a gender difference in B, right? Then you go back to the first table, and you see who score higher? Female, right? Female. So follow the same pattern. The same pattern. There is a gender difference in B, right? Then you report P and P. But this T and P, it has to be the T and P in the second row. And then you say girls that score significantly higher than boys. And then you report mean score and standard deviations for girls. Yeah. Then after that, you report the mean scores and the standard deviations for boys. That's it. That's it. Okay, so this is independent t-test. This is independent t-test. And finally, I want to show you that it's not complex. It's simple, right? But sometimes in your paper, you may examine many independent t-tests. It's possible, right? Yeah, because for example, you have many variables and you want to examine the gender differences in all of these variables. That's possible. So if there are a lot of independent t-tests, I suggest take a look. What's this? What's this? This is EFA, right? This is EFA. You can check this table. This is what? This is an independent t-test, right? You can see gender, male, female, two groups, right? You can see major, science, natural science, social science, two groups, right? Father's education level, mother's education level, two groups, right? So there are a lot of independent t-tests, right? Yeah. So if there are a lot of independent t-tests, if you just use text to report the result, it will what? Readers will be very bored reading all of these sentences because they will be so many differences. So in that case, I suggest that you make a table reporting the result of your independent t-test. That will increase the readability of your paper. Like this, as you can see here, the mean scores followed by standard deviations, right? For each group. How about this line? This column, this is what? This is t-test, right? T-test followed by asterisks, p-values, right? So you report what? Mean scores, standard deviations, t-values, and p-values, right? Yeah, so you make a table summarizing the findings of your independent t-test. And in your text, you can summarize this. Instead, I do not recommend that you report your findings one by one. That's difficult for readers. Instead, I suggest you summarize your findings. The differences, the similarities in your independent t-test. That's better. That's better. Okay, so next time we are going to discuss one-way ANOVA. It's going to be more complex than t-test. Okay. Yeah. Yes, of course you can save the file.
Delete once.
You just save it. Yeah. You can